Okay, so in this class we'll start a new chapter. Okay, so that is your chapter 5. You can write down along with me arithmetic. Okay, arithmetic progression. Arithmetic progression. Okay, the heading of the chapter, and we'll start the first test under this chapter, that is following your exercise 5.1. So under this test, first one, 5.1A, under your exercise 5.1. okay, this will cover your introduction. Okay, I'm writing in short. Then question B2, we'll find this on textbook pages. I'll just include the beginning of the chapter, introduction and all. That is your page 95 to 104. 95 to 104. This question we'll find on the last page, that is on the page 104, but I'm including from 95 because introduction, the concept, introduction and all starts from page 95. Okay, so write likewise along with me. And here the first thing that we need to do here would be, okay, the first thing that we need to do is your sequence. Let us see what is a sequence first. So for that, we'll go very slow in this class because we're introducing sequence. So let us take example of some sequence and then try to explain. Because starting to understand from an example level, right, and then moving to the definition will be easier, right? So let us take a sequence example. For example, I'll introduce to you a sequence 2. Now you keep on adding 2 for each item here. 2 plus 2, yes, 4. Then same number you continue to add. 4 plus 2, 6. Then 6 plus 2, 8. 8 plus 2, 10. So let us say we have here 5 numbers arranged not randomly but in a fixed pattern, in a fixed manner, where 2 is added to each term to get the next term, right? So that is an example of a sequence. Another example of a sequence, let us take example 2. Let us say 2 again, but this time let us follow a different set of rules. Okay, so add to itself. Here adding 2 each time. Here we're going to add each term to itself to obtain the next term. So add to itself, 2 to itself means 2 plus 2, 4, yes. Then add 4 to itself, 4 plus 4, 8. And add 8 to itself, 8 plus 8, 16, right? And add 16 to itself, 16 plus 16, 32. Even in the second example, we are following a definite rule, right? But the rule in the second example is different from the rule in the first. In the first, the rule is add 2 to each term to get the next term. In the second, add every item to itself to get the next term. Add it to itself. Both are following its own rule, right? So when numbers are arranged with a definite rule governing it, such a set of numbers is called a sequence. So now we can write the definition of a sequence. You can write along with me. Okay, you can write below this. Let me write it from here. Okay, so here, from here, let me write. For lack of space, I'm writing here. Okay, you can write below your thing. So a sequence, page starting from 95. Okay, when some numbers are arranged, so now we know the definition of a sequence. When some numbers are arranged, okay, in a definite order, in a definite order, comma, according to some definite rule, according to some definite rule, okay, according to some definite rule, the numbers are said to be in a sequence. So that is your definition for a sequence. Okay, now under this we have to add an important point, so I'm going to add that in a bullet manner, so we can make a bullet. Okay, so each number, EACH, each number of any sequence of this sequence. So if you have a sequence, each item or number of the sequence is called its term. So if we have, what is a term? Each of these are called terms. So 2 is a term, 4 is a term, 6 is a term. Each number present in a sequence are called its term. So there are 1, 2, 3, 4, 5 terms, right? So that is the definition for a term of a sequence. Okay, then, and the nth term. So the nth term can be, depending on each situation, the nth means the fifth term. If n is 5, then nth term is the fifth term. If n is 7, means the 7th item, then the nth term is the 7th term. The value is different. The nth is actually speaking about the position of the term. This is the n is 1, n2, n3, because it's in third position, 4 and 5. So if you take 10, the nth term is the 1, 2, 3, 4, 5. Nth term is the fifth term, or n is 5, right? And the nth term is usually denoted, okay, in most textbook by an, like this, or some textbook also uses tn, nth term. Both are same, right? So that is the definition for a sequence. After your sequence, we'll now discuss what is a progression. Okay, so write it down. This one, you just write the definition for as an information. A sequence, we know what is a sequence. A sequence, okay, a sequence which is arranged or which follows a definite pattern. Definite pattern is called a progression. It's called a progression. So we have learned sequence. Then we have also learned that each member or number of a sequence is called its term, and the nth term is denoted by an or tn. And then we move to what is a progression. Now we're going to have to come to the main topic of this exercise. So after this, write the heading Arithmetic Progression. Okay, Arithmetic Progression. So this is the most important concept that we'll have to get it thoroughly, arithmetic progression, because this chapter deals with this one. So we have learned what is a progression. Now let us narrow it down to one progression, one type of progression called arithmetic progression. For that, let us take an example first, because it's always easier to take an example. So example of an AP or arithmetic progression is usually denoted by the abbreviation AP. So example of an AP, let me take here, give you a real example of an AP 2. Then let us add a fixed number to, this is the first term, okay. To the first term you add, choose a number that you want to add. Okay, 2, then 2 plus 2, 4. So once you've chosen, use the same number, fixed number, not changing. 2 plus 2, 4, then 4 plus 2, 6. Then 6 plus 2, 8, 8 plus 2, 10, etc. So such a progression, arithmetic progression means a set of numbers in which each term is obtained by adding a fixed number, okay, unchanging, fixed means unchanging number, to the preceding term. That means except the first term, write it, then the second term is going to be obtained by adding a fixed number to the preceding, means the one in front. So in second term, so the one in front is the first term, so add a fixed number to the first term, 2 plus 2, 4. The next term, third term, will be obtained by adding that same fixed number 2 to the third term, means preceding term is second term. To the second term you add a fixed number, 4 plus 2, 6. So an arithmetic progression. Okay, so we can now write the definition. Therefore an arithmetic progression is a list of numbers, okay, it's a list of numbers in which each term means each of these items, term means, in other words, item, in which each term means each number or each term is obtained. This is important and the key definition for a arithmetic progression. For each term is obtained by adding a fixed number, okay, fixed number, by adding a fixed number to the preceding means the one in front, preceding, as I've already told you a moment ago, term, except the first term, except the first term. So we should not add the fixed number to the first term. First term just write as it is, and the second term will be obtained by adding that fixed number to the preceding term, means to the first term. Add the fixed number to the first term, you'll get the second term. Add that same fixed number to the second term, you'll get the third term. Add that fixed number to the third term, you get the fourth term. So each term is obtained by adding that fixed number to the preceding term, okay. So that is the definition for arithmetic progression. Important points to note here. This first one is, under this arithmetic progression, is the first one, common difference. D, put a bullet point, the fixed number that you use in AP. The fixed number is called the fixed number is called the common difference. Okay, the common difference, usually denoted by D, small d, okay, is called the common difference. Okay, so this fixed number that was added to each number to get the next term, okay, each term is obtained by adding the fixed number to the preceding term. That fixed number is called common difference. It can be positive. This common difference can be positive or it can be negative, or it can also be zero. Let me just show it. Okay, the fixed D can be positive, D common difference can be negative, common difference can even be zero. So let us take some examples to see. and for ourselves that it is so. So example, first one, take the two same one and then add 2 to the common difference is now, if you if you subtract a term from the first, a term from its preceding term, you get the common difference. Okay, so here see 4 minus 2, 2, so common difference is 2. So 2, don't add anything, first term just raise it, is except the first term, don't add to the first term, just write it, then keep on adding. Each term is obtained by adding that fixed number to the preceding. So second term will be obtained by adding that fixed number is 2, so 2 to the preceding means second term, means preceding one is first term, 2 plus 2, 4. Then to get the third term, add that fixed number to the preceding term, 2 plus 4, 6, 2 plus 6, 8, and here 2 plus 8, 10. So adding that fixed number to the preceding term, we got this AP. This is definitely AP because they have a common difference. That means the fixed number is there, the fixed common difference. So here you see here D is equal to, how do you obtain D? Subtract a term, okay, a term minus its preceding, whatever here, 4 minus 2, 2, 6 minus 4, 2, it's going to be same if it's AP. So 4 minus 2, so is 2, common difference is 2, which is, here you can clearly see, here common difference is 2, and therefore you can clearly see it's positive. So common difference here is positive. So this is correct, common difference can be positive, correct. Then example number 2, it can be negative also. So let's just go the reverse. The first term be same. Now let us say common difference is minus 1. So it should not change. Common difference should be minus 1 throughout. So 2 minus 1, 1, right. 1 minus 1, 0. Then 0 minus 1, minus 1. Then minus 1, minus 1. Adding that fixed difference is now negative, right? Minus 1, minus 2, etc. So here you can clearly see D is minus 1. So which is, we can see that common difference can also be negative. So you tick here correct. How can common difference be 0? Let us see. Let me give you a sequence here. Let me just write minus 2, minus 2, minus 2. This is definitely a AP. How? Because you see here, minus 2 plus 0. We get the next term by adding the fixed common difference is 0. So 0 plus minus 2, minus 2. Then 0 plus minus 2, minus 2. 0 plus minus 2, minus 2. 0 plus minus. So the common difference is 0 here. So here D is 0, and so we can see that common difference D can also be 0. So this statement is true. Fixed common difference can be positive, negative, or 0. Okay, the common difference of an AP can mean positive, negative, or 0, we have proven. Okay. Next here, once you're through with that, we are still under AP, arithmetic progression. After this, another important concept. So here, we are in the common difference. The fixed number. So yes. Now how can we obtain a common difference? Right, this second bullet point. If, okay, A1, A2, A3, etc. is an AP, then, okay, then common difference D will be given by, always this is true, okay, if you have an arithmetic progression, an AP example, A1, A2, A3, A4, etc., then it's always a term A2 minus its preceding. A term minus its preceding, you do that and you'll get your common difference. That can be, so A2 minus A1, or a term minus previous term, okay, not previous term minus a term minus previous term, so it can be A3 minus A2, etc. That is, D can be A, let me show you, and then one more you can go if you want, A4 minus, the just ahead of A4 will be the item A3, so it goes on like that. So let us do this here, take this one, and here 1 plus 1 I can write, minus A1, A, look at this one, 2 plus 1 you do, then 3 you're getting same, minus A2, A3 can be written as is here, look at this one, 2 plus 1, 3, matching, then here A, to write this, here write this one, 3 plus 1, matching, 4 or not, check, yes. So you can rewrite this first one in this format. It's the same. 2 is 1 plus 1, 2. 3 is 2 plus 1, 3. So I can change this into a different format. A, 4, 3 plus 1. That way I see here a common pattern following. So the formula for D can be written as, that is, D can be written as, commonly representing all this, a term. Okay, look at this one. Let's better take this one. Here, see here, let this 2 and 2 are same, let it be K. KB2 in this case, then K plus 1, 2 plus 1, 3. And here, minus AK. So this is the formula for finding a common difference. Common difference is a term minus preceding, because K plus 1 is a term, then the one in front of AK plus 1 will be AK, the one in front, item number in front. So this is the formula for finding common difference. Then the next important point here, this is very important. One important formula we've discussed. The next important formula that we need to keep in this one is if A1, A2, A3, okay, you can just say commonly if A is the first term, if you know the first term, that means, in other words, of an AP, if A is the first term of an AP and D is its common difference, then we can easily write the AP without any problem. How? You see here, write the first term. Okay, you can easily write the AP, comma, you can add this one, which is given by the formula, given by, how do you write the AP? If you know A, the first term, and D, the common difference, you can write the whole AP without any problem. So you write here the first term without any hesitation, then the second term will be formula A plus D. Then the third term will be A plus 2D. And increase once more. First term you write plus 2D, so here 3D. So applying this formula here, if you know A and D, very easily you can find the AP by writing it in the format of, write the first term as this, then next second term A plus D, third term A plus 2D, fourth term A plus 3D, etc. So we can write it like that with this formula. So we can write this one also, and remember how to write an AP easily when we know A and D, small a and D. Now here another formula, the nth term. The nth term can be the 5th term, 7th term, 3rd term, 20th term, 25th term, whatever. the position, n indicates actually the position of the term. Okay, so if you want to find out the value of a term in a particular position, the 5th position or the 25th position, whatever, nth term, okay, nth term of any AP or an AP, okay, is given by, of an AP is given by, denoted by an, and is given by the formula first term plus n minus 1. That is the n is the position of the term that you're trying to find. So if the position is, you want to find the first, second, third, fourth, 5th term, then n will be 5, 5 minus 1. First term plus n minus 1 into common difference. This is the formula we use to find out the value of a term in a particular position. The nth term means the value of the nth term is first term plus n minus 1 into common difference. So keep these 3 formulas especially in mind. Common difference we find by the formula d equal to a k plus 1 minus a k. Then if a and d are given, then we can easily write the AP by following the formula or pattern: a, the next second term, a plus d, third term, a plus 2d, a plus 3d, like that. And the nth term of any AP can be found out by the formula an, which means the value of the nth term is equal to a first term plus n minus 1 into d common difference. So 1, 2, 3 formula, the ones in the boxes especially, are going to be crucial, okay, because they're important in solving the numericals. So we'll now go to the exercise and go to question here, B2. So under this exercise, let's frequently remind ourselves of the 3 main formulas here, and they are, the first one is here, common difference formula, d is equal to a k plus 1, okay, minus ak. And the second formula is, if you know a and d, then writing the AP is very simple. The first one, just write the first term, then a plus d second term, a plus 2d, etc. A plus d, a plus 2d, etc. is the second formula. Then the third formula is nth term, denoted by an, is given by, okay, just write in short, an, which is the nth term, is given by here this formula a, the first term a plus n minus 1 into common difference d. A plus n minus 1 into common difference d. So these are the 3 main formulas we're going to have to keep in our mind. Let's start with question B2. Go very slowly because we're beginning the chapter. So page 104. Write the 4 terms of the AP when the first term a and common difference are given. When the first term a and common difference are given, we write the AP by using second formula, a, second term, a plus d, a plus 2. So we're going to use second formula. So here, subheading 1, here a is given as 10 and d is given as 10. So we learned just now that if we know small a and small d value, which in this case is 10 and 10, we can write easily the AP. In this question, we have to write the first 4 terms only by following this second formula. This one we're going to use. So here you can write your answer here, or you can just do like this, look into your text and write. Here we are given number 1, 2 subheading 1. Here we are given a equal to 10 and d is also equal to 10. Therefore, the first 4 terms of the AP are, and then use this formula, A, comma, then second term is A plus D, third term is A plus 2D, A plus 2D, and the fourth term, we write only up to the fourth term, so A plus 2D here, so 3D. First term, second term, third term, fourth term. Up to A plus 3D only we require. That is the four terms of the APR. First term, A 10, so we just write 10, comma. Second term, A is here 10, plus D is also 10, comma, and here A 10 plus 2 into D. D is again 10, close the bracket, and finally here A is 10 plus 3 into D, again 10. So we can easily write the first four terms, that is the four terms are 10, 10 plus 10, 20. Do this one first, 2 tens are 20, 20 plus 10, 30. Then here also 3 tens are 30 plus 10, and 40. So the first four terms, the first case are 10, 20, 30, 40. This is definitely an AP because they have a common difference. 20 minus 10, 10, 30 minus 20, 10, 40 minus 30, 10. So there is a common difference fixed. The only qualification for a set of numbers to be AP, arithmetic progression, is they must have a common difference, right? I will give you an example of what is not an AP. You can just write a side note here. Yeah, so here, for example, 2. It's a sequence, but not an AP. Example 2. Add to itself 2 plus 2, 4. Add to itself 4 plus 4, 8. Add to itself 8 plus 8, 16. 16 plus 16, 32. It's definitely a sequence because it's following a definite rule. That is, a term is added to itself to get the next term. But this is not AP because the difference is, common difference is, it doesn't have a common difference. 4 minus 2, here 2. The difference between these two, 8 minus 4, 4. Then here 16 minus 8, 8. So they don't have the same fixed common difference. So it's not an AP. AP means they will always have common difference. 20 minus 10, 10. 30 minus 10, 10. See, fixed 10, 10. Difference is fixed. This is not fixed. Difference is 2 in the first case. Between this next 2 is 4. Between the next 2 is 8. So it's not fixed. 2, 4. The difference is not common, right? Okay, so let us go to the 2. So number 2. Here, A is minus 2 and D is 0. A is minus 2 and D is 0. You write it likewise. So here, this is 2, okay. Subheading 2. The first four terms up to here will be same. Let's write it because we have to follow the second formula. First four terms, first A plus D, A plus 2D, A plus 3D. 1, 2, 3, 4. Only up to the fourth terms. The question is same. So that is, now let's do it together. A. So write the first term is this. It is minus 2. And comma. A again here. A plus D. So A is minus 2. Plus D. D is here. 0. Okay, so you write 0. Then comma. A is again minus 2. Plus 2 into 0. 2 into D, 0. And A is minus 2 plus 3 into D is again 0. Write it carefully. Then you can write that is minus 2, comma, minus 2 plus 0, minus 2, comma, minus 2. Okay, go here. 2 zeros are 0. 0 plus minus 2 is minus 2. 3 zeros are 0. So minus 2 plus 0 is, because this is 0, 3. Anything multiplied with 0 is 0. Minus 2 plus 0, minus 2. So sequence is minus 2, minus 2, minus 2, minus 2. It's same because the common difference is 0, right? Next one, the third one. Here the common difference is Let's write it down carefully. A is 4, D is minus 3. A is 4 and D is minus 3. So up to here you write same again. Okay, write the same. So A here is 4, so write that one. That is 4, the first term. Second term, A is 4 plus D is minus. Since there is a minus, let's use a bracket. D is here minus 3. So I hope you got the A 4 plus D minus 3. Since you have used up the first bracket, and carve it up with the second bracket indicating this is the second term, comma the third term, A is 4 plus 2 into D is again minus 3. Bracket means it multiplies, it indicates multiplication also. First bracket used, so to block up the third term, you just write like that. And finally the fourth term, A is 4 plus 3 into D is minus 3. A plus 3 into D, cover it up with the second bracket and do slowly, carefully. So the first term of this series is 4 plus 4. Second term is 4 plus and minus minus 3. So this bracket removed because outside and inside signs are multiplied. Similarly, 4 plus and minus is minus. 2 3s are 6 and 4 plus and minus minus 3 3s are 9. That is the first 4 terms are 4, comma. Then your 4 minus 3 is plus 1. 4 minus 6 is minus 2. Because minus 6 plus 4 is subtraction. 6 minus 4, 2. Bigger absolute value is 6 and its sign is minus, so this 2 will have minus. That's why I wrote here 4 minus 6 minus 2. Likewise 4 minus 9. I don't think I need to show you on the rough, right? 4 minus 9 is minus 5. It's minus because the bigger one is minus. So you can write here and minus 5. Then the fourth one. Two more are there, I think. A and D. The fourth one is A minus 1 and D is half. Right up to here same because we're going to use the same formula. Let's do carefully, write it down. Okay. So that is first term very easy, A is minus 1, comma, second term here A minus 1 plus D is half, comma, A is minus 1 plus 2 into D is here 1 by 2. So into means I can cancel this 2, 1, 1. 2 ones are 2, 2 ones are 2. And the fourth term is A here minus 1 plus 3 into D here is 1 by 2. Write it carefully. The next one, that is first term is minus 1. Here plus and minus, minus 2 ones are 2 plus, since you multiplied, this one will be same. Multiplied, so the long line will cover up to here divided by 2. So this is the second term. Likewise here, 2 to cancel, so everything cancel. Minus 1, 1 ones are 1 by 1, 1 by 1. Here plus, 1 ones are 1, 1 by 1 is 1. So here minus 1, here 1. Minus 1 plus 1. And here you see, minus 1, 3 ones are here plus first, then 3 ones are 3 by 2. We have to deal with this one more step. That is the first term is minus 1, second term is minus 2 plus 1 is minus 1, minus 2 plus 1 subtraction, 2 minus 1, bigger one minus, so minus. Minus 2 plus 1 is minus 1 by 2 is the second term. Minus 1 plus 1 is 0. And then the fourth term we have to deal one more step. 2 ones are 2. Plus and minus, minus. And this one plus, then here nothing will change, same 3. Since you multiply the LCM long line by LCM. So this is the fourth term. Finally, we'll go one more step and write here that is the first four terms of this series APR -1, -1 by 2, 0, and the last term is -2 plus 3 is +1 by 2. The fourth, and I think there is one more fifth one. So we write here fifth one. Here A and D. Fifth one is -1.25. Okay, -1.25, and D is -0.25, -0.25. Up to here will be same formula, so write it down. Okay, so here, once we're through, let us write it slowly. A, the first term is, that is -1.25, comma, A again, -1.25, plus D, again minus, so there is a minus, so I put a bracket, -0.25, close it with a second bracket, indicating the second term. A plus D minus, that's why I covered it up with a bracket to separate these two signs, plus and minus, comma, the third term, A is -1.25 plus 2D, so 2 into D is -0.25, so into can be indicated by putting bracket like that. Cover it up with a second bracket, and the fourth term is -1.25 plus 3 into D -0.25. So these are the four terms. So let us do slowly. So that is first term -1.25, comma. Then here's second term -1.25 plus and minus -0.25, comma. Third term -1.25 plus and minus 2 5s are 10. 2 2s are 4 plus 1, remainder 5. Then 1 2 decimals 1 2. So -0.50 is the, or 0.5, 0.5, 0.50, 0.500, all are same. Okay, so 0.5 or 0.50. That is the third term, and the fourth term is -1.25 plus and minus 3 5s are 15, 3 2s are 6 plus 1 7, and 1 2, so 1 2 is 0.75. So these are the four terms. So we have to write carefully, that is -1.25, comma. On the rough you can do now. Here we don't need these steps, so I'll just run it out. First one, -1.25. We know that when we're adding or subtracting, the decimals should be on the same line. So this one point, you write same line, and then 25 on the right side, and on the left 0. In front is minus. When both are minus, we know we add. So 5 plus 5, 10, 1 in hand. 2 plus 2, 4, plus 1 remainder that we got from here is 5, and point. 1 plus 0 is 1. When both are minus, we are adding. When both are minus, the sign in the answer will also be minus. So -1.25 minus 0.25, this one is -1.50, means -1.5. Then comma, here -1.25. Here point should be on the same line. Right side is 50, on the left side is 0. And here also minus. Again both minus, so add 5 plus 0, 5, 2, 5 plus 2, 7, 1 plus 0, 1, and both minus means here also minus. So this one will be -1.75, and the fourth term here -1.25, and here point on the right side is 75, on the left is 0, both minus, so add 5 plus 5, 10, 7 plus 2, 9, plus 1 remainder, 10, 1 remainder, so 1 plus 1 is 2, both minus, so here minus, so 2.00 means minus 2. So this first 4 terms are this. That concludes the part for test 5.1A. I hope you're getting it. So as in this chapter, okay, an arithmetic progression is a set of numbers in which each term of the AP is obtained by adding a fixed number to the preceding number. So if any set of numbers satisfy this condition that every member or every number is obtained by adding a fixed common difference, a fixed number to the preceding term, that's called an AP. Under AP, the common difference is given by the formula D small is the common difference, AK plus 1 minus AK. Then if A and D are given, we can easily find the members of the series by this formula. A, first term, second term, A plus D, then A plus 2D, A plus 3D, keeps on going till as much as we want. And the nth term of an AP can be found out by the formula An is equal to A plus n minus 1 into D. A plus n minus 1 into D. Again, D is common difference can be found out A k plus 1 minus AK. Then if A and D, that means first term and the common difference are given, then we can find the members of the series AP of the members of the AP by using the formula. Write the first term A, then A plus K, then A plus 2K, A plus 3K, like that. And the nth term of an AP can be found out by the formula An equal to, okay, A plus n minus 1 into D. These three formulas, thoroughly memorize it, and not only memorize it, but understand it and keep it well in your memory, okay, because it's going to be important and crucial to remember this to solve the questions under this exercise 5.1 and 2. Okay.